Hello everyone. Good evening, and I'll just give a few seconds intro about myself and my background before I go into this. Right. So, IoT is a very big word. That's why I want to do it. Make some baselines first. Okay. I am an engineer by heart. Currently, I do marketing for a company called Tata Elxsi. What we do in that company is everything about electronics and system integration. That's why it's called EL cross SI, right? It's basically out of electronics that the whole company started. And embedded systems, I've been all through my 16-year career in Tata Elxsi, fully doing things on embedded multimedia, video, set-top boxes, DVD players. One of my favorite was, how many of you have Canon cameras? Use it. So do you use the Wi-Fi feature in? Okay. So if you buy any Canon camera that has a Wi-Fi, it runs Stack, and I'm very proud to say it runs my code as well. Okay. So no, thanks. And there's a big team to thank. Okay. It's not just me. Yeah. So I'll share some learnings from that. Right. And the whole idea of what I'm going to do here is talk about IoT from the perspective of embedded. Right. And from how, because IoT typically is a big word with different definitions for different people. So how do we define IoT, right? So you talk about sensor networks. That's the first thing that comes to mind. Anybody says IoT. Then you talk about devices to control the network, to control stuff on the whatever you have deployed. Then you talk about a platform where probably there's somebody else going to talk about a big platform today. Analytics is a big subject by itself, right? So how do you do basic analytics to a great AI-based predictive, whatever, autonomous stuff? And then you actually come back to the application. I purposefully have reversed. Typically, it's the reverse way people put, right? So it's sensors, control, platform, analytics. So because I would to actually focus on the sensor network and the control devices kind of areas, which are more to do with the embedded today. And just give my learnings and perspective about what I've seen and what different industry players are doing and what I have in my interactions come across, right? So that's what would be my core. How many of you have experimented with some sort of embedded system here? Just to get a feel. 1, 2, 3, 4. Oh. You guys use a Mac? How many of you use a Mac? Almost everybody should have touched it, but I consider Mac as an embedded system because you can't touch anything and change anything to your free will. Okay. Yeah, just on the lighter side. So we all are familiar with this Raspberry Pi. You get a Debian, you get Linux. I'm sure you're familiar with this, even if you're not tinkered with it enough. Python, Ruby, we're all familiar. It comes from the server world, in fact. And there is a hell lot of software from the Debian ecosystem that is just kind of plug and play. You just install and it works. And today you have JavaScript on the application side, right? Johnny 5.io, Cylon. I'm sure you guys are much more familiar with what could be the libraries and the stack for IoT that you can plug in for your application needs. But okay, so these are some examples of hardware platforms, right? The embedded stuff that actually does some sort of intelligence that builds in and sends your data back into the cloud or the application that you're building. So you have a Raspberry Pi, for example, you have Intel Edison or the Galileo, you have certain very different flavors of Arduino. So this is good for this 6.5 billion embedded devices that is expected to be there in the next 5 years, right? This is the number that we're talking about in 2020. And this is Gartner. Different people have different views on Gartner, but at least let's take the number as one baseline to talk about, right? So how much does a Raspberry Pi cost? So how much does 6.5 billion Raspberry Pi cost, right? Now this is the first perspective that we need to understand, right? That the device and the sensor becomes one very critical part in your solutioning for IoT. So these are some of the microcontroller unit platforms that comes in. If you have used Raspberry Pi, you would know that Broadcom is the chipset in that. Now, can somebody just brainstorm on what are the features of Raspberry Pi? If you have just what you know, people who have used it, few people. So, okay, yeah, go ahead.
So it can communicate to sensor nodes.
Great.
Information from different sensors, like several sensors or whatever.
Sure. So you use Raspberry Pi as a collector or aggregator of data. Okay. But what is inside the Raspberry Pi? What is inside this Broadcom chipset? What are the things that enable? Yeah, you have ARM Cortex. Then Wi-Fi module. I think it's add-on to. Okay. So let's take it. It's add-on. Fine. Adapters. Okay. It has a video out, right? It has a GPIO. It has a mic in. So do you need that HDMI video out, or whatever the new one provides? You can put cameras on it. But do you really need that in all the IoT applications? Now this is the question you want to ask yourself, right? How much of that hardware would you actually need to build your solution? So people like Qualcomm, people like, this is a platform for IoT from Cypress, or Renesas, they have custom built IoT platforms, right? So that is targeted at certain applications, which says, okay, why do you want to spend? The Broadcom chip itself may cost $8 to $10 if you are building a product, just the chip, right? Because it can do HD decode. It can even encode HD, actually. It's so powerful. It has OpenGL support. You can do OpenCV on it. Who's going to do OpenCV on 6.5 billion devices? You won't do on all the devices, right? So you choose the best platform, and there are multiple players today who are trying to give you solutions very specific to that application, right? And this is one of a company from China, which has built a custom chip with Wi-Fi. It has a Tensilica processor, which is probably 80 to 100 megahertz, and it has Wi-Fi. That's it. And that's good enough for a lot of IoT applications that you would probably envisage, right? It may not be for all, but for certain applications. So you choose from this ecosystem, and there are more. Okay, this is not everything. I just try to bring some examples. I mean, just to make a point, right? This is the kind of Raspberry Pi power architecture, right? Now you see there is a micro USB, GPIO, HDMI, SD card. You may not need everything, right? And you choose only what you need. How would you do that? You can't do it just by buying Raspberry Pi off the shelf. You would have to build some custom board, some custom hardware. And that is when you would actually find your boundaries moving from a hobbyist to a product developer, right? To a production quality IoT solution. So that's the challenge. And think of the power, right? 6.5 billion devices, even if it is 0.1 watts, what is the amount of power you're going to actually utilize just to connect all these devices? So you wouldn't really want to waste even a milliwatt or even microwatt for that matter. So you should be very conscious about it and choose the right hardware platform. So Raspberry Pi is a general purpose computer. Let's understand that first, right? We all use it. We all tinker with it. We build interesting stuff, a lot of prototypes, POCs, very interesting, great. But it stops there. You go into the real world, try to put, say, 10,000 Raspberry Pis for an oil guy, you're doomed. He's not going to buy your solution. Nobody can invest that kind of money just in the hardware, right? Then you will talk about software, then you will talk about operations. So it's not practically feasible to just do products just with Raspberry Pis and Arduinos. You need to go beyond that. So how would you actually go about choosing a hardware? Some of them are generic. Please stop me if you find it too boring or too generic. I can go deeper. And some more slides, I go a little bit more deeper. So you would probably think of compute power first, right? What is the compute power you need for the application is more important than what is available. You could run a 2 gigahertz Raspberry Pi Broadcom chip. It doesn't matter. If you don't need 2 gigahertz, don't do it. Just do 80 megahertz. Okay. For example, the Canon camera we developed. The Ethernet can do 800 megabits. It's a gigabit Ethernet port, which can actually do 800 megabits per second, right? A real life example. So it's very rare to get 800 megabits per second. Most of the products will give you only 600 megabits per second, even today, okay? But we used only 180 megahertz processor to deliver that performance, okay? How would you do that? You actually go down. You don't stick to JavaScript and the application SDKs. You go down to Ethernet. You go down to the driver. You go down to the interrupt. So I'll give you one example that I had worked on. So for example, there was this. We got around 500, 550 megabits when initially we put all this driver and all the regression, and we couldn't push it beyond that. Then one thing I measured, the OS is something Linux-like. It's not Linux, but it's similar to Linux, the interrupt architecture and everything. Yes. So I measured the cycle time between whenever you get an Ethernet packet, you just get an interrupt to the processors, right? From that point till you come to my driver code to process the first byte of a packet, it used to take around 11,000 cycles, 11,000 CPU cycles. What does this do for 11,000 CPU cycles, right? Okay, then it's all about the kernel. It will think, okay, interrupt has come. Let's put it in one queue, push it into one buffer. Then you wait because somebody else has come. Okay, then schedule, round robin. Then another priority task will come. So it does 100 things before it hits my processing code. So we changed something very small, right? So we took a few lines of my header byte processing and put it in the driver itself, right? In C code. The code is in C. So what happened? Okay, we reduced from 11,000 to around 5,000 cycles. Okay, and what we did, nothing. The same code, it is running in a different place. It is not like I optimized the code or I did something massive, right? But it was not enough for us. Still, the performance doesn't meet our benchmark, right? So then we rewrote the whole code, this piece of code in C, which does the interrupt handling in assembly. And people still call me crazy. Why do you want to write things in assembly? You should go and learn Java first. Okay, so yeah, there are some people in this room who say that. So we could reduce it to, you won't believe, amazingly, 80 cycles, 80. And that's how you achieve 800 megabits, right? So this is a real life, my own example, my own learning. So there are things that you would want to optimize and choose just for the problem. Think of the problem first and then choose what you want. Something, please don't force it on yourself to the solution, right? And this very much is important for the hardware. So compute power, memory, the IO and peripherals, what you need. Do you need a camera interface? If you don't need it, throw it away, because every interface you add, it consumes power. Okay, I will just show you something here. So there's something called a buffer here. Whenever you add an interface, you see these ports on this boards, right? So you would add a buffer here. And these buffers are kept on all the time because they have to handle interrupts. And each buffer consumes current, okay? A few microampere current. And if you add all this interfaces current, you would actually arrive at a milliwatt calculation. And each milliwatt is a problem for you when you go for IoT. Okay, so that's why you need to actually be very conscious. If you don't need an interface, throw it. Every single wire is a problem for you. Just throw it. Don't bother about it. Okay. Sensors. So what sensors you need? And this is typically built in the chipset today, right? So you would actually choose the chip based on the problem, based on what sensors you need. Don't choose sensors which you don't need. At least you would want to make it future-proof for sure, but let's not be too unrealistic and think, okay, this will work for 100 years. No, it may not, right? So you can plan for, say, 5 to 10 years of a life cycle, but depends on the problem. You know, don't go to defense and say this, they'll kill me immediately. They need solutions for the next 100 years. Okay, so Yeah, that's another important thing. Grade of the chip, right? When you choose a hardware, Raspberry Pi chips are consumer grade. They're not made robust enough. They're not even defense grade, right? Then you have space grade. So you would want to choose what grade you want, and then come to your problems. Okay, this is solve my problem. Now, the temperature variation, radiation can affect. That's why they have space grade chips, which you put in satellites. Okay, they're different. They're not the same stuff as what we use here. They're very expensive to make as well. So that's because there are radiations which can malfunction your chip because there is no atmosphere in space, right? It's a simple logic, but we don't think about it so much. So we have to be very conscious. Where is this going in the field? Okay, I'm going to put it in some desert, oil well, under the sea. IoT can be anywhere. So please think about it. Tool support, this is a no-brainer. Cloud support, yeah, ultimately this stuff has to interface with whatever platform analytics and application you choose. So you need the right interface. And finally, the cost, which is a very big element when you consider large deployments and real problems, right? This is a comparison I took from an article, good article, I believe, a small article, but it is just a comparison of some of the platforms, right? To say how he is compared on compute memory, IO, and stuff like that. So if you see, for example, you have Atmel, the 48 megahertz processor, and you have a 550 megahertz dual core, dual threaded imagination, right? And then Marvel, and there's a 200 megahertz. So you have a wide range here, right? And then you can also see the amount of flash memory, 8 MB serial. This is a 512 MB NAND, there's 8 and this 512, right? So you would have a lot of choices to make, and then there is enough of choices. So please choose it again very judiciously. We talked a little bit about IO. You have a wide variety there. Some of them support camera, some of them don't. So wireless, interesting stuff, right? So most of this listed here is Wi-Fi and BGN. Maybe this table is a little bit old, but I think if you talk about LoRa, if you talk about the new protocols that are coming, you would actually want to see how much energy it consumes. One of the biggest, all of us have mobile phones, so it's a no-brainer. If you switch on 3G, 4G, your battery goes down faster, right? It just means your wireless consuming more power. The wireless is a separate chip all the time. It's a baseband chip. So it will suck power because it has to always scan the airwaves to see if I'm getting a signal. That's the first energy sucking thing in your wireless device. So you would want to choose a wireless protocol that is apt for your application. Two, when you design stuff, keep the wireless on only to the required amount of time, just like how you would manage your data part in the mobile. Many of us, I believe, do that. We are in India, so we don't get free data so much, right? So yeah, and the mobile power also. So please think of the same stuff here. It's not a big deal, but we forget it when we design. That's the problem. And then you have cloud connectivity. Some of these platforms support, for example, if you want to connect with IBM, you would probably think of a platform that supports that, right? These things are not readily available for your Raspberry Pi or Arduino. Maybe that solves your problem, but when you move this side, when you move to the support, you would start facing issues. Okay. By the way, this cost is the cost of the kit. All these platforms are available for you. You can just buy them online or just contact the chip vendor. You can just buy them. And this is the cost of a kit, not cost of the chipset. Right? The cost of the chip will be much lower than this. And it depends on volumes. So, if you are interested and want to experiment, all these and all these logos I shown earlier, developer kit today. And most of them also give you open source support. So you can go beyond Raspberry Pi and Arduino and try to experiment with these. And yeah, and this is just a slide I picked up, which might be interesting. This is on the low power Wi-Fi, because if you consider power and wireless, you have to balance this, right? There is proprietary stuff, technology like Sigfox provides. And there are open technologies that these consortiums are actually actively promoting. So you again have a wide choice of technologies, right? I have seen some deployments using 4G narrowband. In 4G, they have a narrowband protocol, T standard, which is made devices, right? And there are real-world deployments already. I know some solutions from Huawei. For example, there's a fleet management solution, which actually tracks some few million vehicles on the road, right? And that uses your narrowband part of the LTE. So you don't need to consume the full LTE bandwidth, just like how you're doing the data, normal data transfer. I'm good on time or bad? Very bad. Yeah, okay. Okay, so I'll just take an example just to make it clear. I'm not selling Renesas here. Okay, I just picked up because I found this more graphically interesting and easy to communicate. So see, this is how Renesas used to provide a stack earlier, or most of the chip vendors used to provide a stack earlier, right? So they used to give you, let's say you buy that developer kit. Earlier you would have to struggle because they'll give you a few tools, good, you'll get a compiler and some basic libraries, and they'll give you some example code. And they will say, they will give you a document on how to connect to the cloud or how to write code above that. That's all, right? And then they'll tell you, okay, this is the series you use. You know, there are enough numbers and confusion between those numbers in the chipset today. But they will tell you at least, okay, you use so and so number series, and this developer kit will work on that series. And it's up to you to figure out if the combination works. Okay, and then they'll give you a basic RTOS and a few software add-ons with the API. This is how a stack used to look a few years ago. Let's say 3 years or 4 years ago, right? Not very long. And you know, Renesas and other companies, they actually discovered that this support I'm giving for the MCU is just tip of the iceberg, right? And that's what the diagram indicates. And there is so much more to do for people to come out to the product, right? So you will have to support in research, acquisition, training, development, whatever is listed here, verification. You know, you build a product, how do you verify, test it? Where do you go for these tools? How do you automate these things? How do you even know what to test and what not to test, right? So, and of course, on the ops side, upgrades, supports, and maintenance. So a product involves much more than just that first part, right? And that's the solution your customer or your project will need. So today, at least, they have gone one step higher. Most of the silicon vendors will provide you RTOS plus, you know, a file system, a basic USB library, networking library, graphics libraries. So at least they give you a better base and a foundation to start with. So I like some of these companies because the foundation is much better. And by the way, these stacks are very much tailored for the application. For example, if you talk about Renesas, this Synergy platform, right? They are made for energy domain. Okay, so you can build a smart meter, for example. You can build something for energy management. There's a building energy management. So you can choose this chip for that because the sensors provided, the power ratios, the power of the MCU, the software stack. This package comes to you for a particular problems domain. Okay, and you may go to different company. You may go to TA for a different domain. You may go to NXP for say automotive, right? So you would have to choose silicon based on the application, based on what is your problem basically, which domain the problem comes from, right? Yeah. Okay, so I'm just trying to summarize what is the approach we can take to get into a real world, right? So proof of concept, yes, cost really doesn't matter because you would not do so much in the proof of concept. You can choose Raspberry Pi, whatever works, right? Just to show that, yes, you know, this is a concept and this will work. That's all. And once you go beyond that, you will come to benchmarking. Now, the next step you would have to do is benchmarking and understand what is that subset, what is that package of the chipset, the sensor, the memory, the software stack, and the cloud connectivity that works for my problem, right? And so you would want to benchmark and compare. Without this, please don't just jump into the platform and solution, right? Then prototype. Prototype you would actually base on your benchmark, but suggestion is that go as close as possible to the product and your solution. right? And try to please prototype. I know lean works. This is lean, but 98% of that lean. Your hardware iterations are obviously very long and very time consuming and expensive, unlike application iterations, right? Today, at least you have so many platform choices, a lot of open source code available on those platforms. Your iterations are smaller, but still iterate as much as possible in your benchmarking and then go here. You can still save cost, time, everything, your own energy, right? And a lot of oil burnt in the night. So yes, and then one thing in the prototype, we miss usability designs, right? I know I'm talking about some low-level hardware, sensor, all these things, but there may be one sensor you are missing, which that service guy wants after you deploy your solution in the field. Okay, think of him. That is the guy who is actually going to use your solution on a day-to-day basis. And usability, you please think of it even at this stage, and think, will this be usable by all your stakeholders, right? Whatever hardware you are choosing, will it help to build the application that will be used by all your stakeholders? So these are the kind of a holistic design philosophy comes in. So please think of it. In terms of B2B solutions, it becomes serviceability. But if you're looking at a consumer-facing product, think of the consumer usability, right? And then do your prototype and include as much usability as possible, a usability part as possible in that, right? It will help you to learn more and make more mistakes early, and then come back faster. So then cycle, obviously you would go around wherever you made mistakes, and please, I'm a tea person, so I will go with tea in the nights. People who drink coffee can take coffee. And yes, please think of the cost. Once you have the proof of concept, all this, please think of cost of your end solution, not just cost of the hardware, not just cost of the software, application platform, cloud subscription, whatever, but please work out a holistic cost and look at, will that solve my near-term and the long-term problems, right? And I think after proof of concept, you will start breaking your head on this. Everything you choose and everything you leave will have an impact on the cost. And we are talking of large scale numbers in terms of IoT, right? So this will be a very important factor for you to consider. And please have satisfaction by doing all this. I hope you'll gain satisfaction and enjoy, right? So thank you. Take away. Please choose your problem. If you have to go back and try something out, right? Tonight, I don't know how many of you have platforms, but at least you can contact the silicon vendors of your choice. Choose your problem first before contacting the silicon vendor, and contact the right silicon vendor for the problem, right? And then choose your platform based on your problem. That's what I would say. Let's not choose just because I have something at my disposal. Okay, try. You can try it. Tinkering is fine, but I'm talking about building a solution, right? And then please solve it. Enjoy it. Thank you. Any questions or?
More interested in communication protocols.
Yeah.
IoT is all about user communicating. Yes, with what you explained, it's very important. At the most granular level in understanding.
Yes.
The business perspective of IoT. But what about when I'm using audio and stuff like that? They have all the communication architecture for ability connect with the receiver.
Right.
You no need to take care of all the communication part. You just connect it, deploy it, and go to
Correct. Correct.
But what if we are going, we are writing everything from scratch, the communication protocol, the platform, everything from
that's
scratch.
A lot of work.
That's a lot of work.
Yeah.
So that would also,
so why would you want to write everything from the scratch?
if I'm using Azure.
The communication part alone, everything. Yeah. So that.
It also
Correct.
will be a lot of cost.
Correct.
So
Correct.
if I'm having around 3 episodes, okay, communicate again, the cost incurred would also be on after the deployment. The running cost of the mission.
Yes.
So that is what.
So from a communication protocol, see, that is where you would work closely with the silicon vendor to give you that support first, right, as much as possible. So if you have chosen AWS, you would actually probably pick the silicon vendor who is supporting it, and then try to ask him, boss, these are the more support I need. It's easier that way because he's going to support a few thousands of customers across the globe. So they write it once and give it to you. And typically the software, they don't really care. They don't charge you much, right? And they don't actually, it's free. If you have something specific, yeah, they leave it to us, right? And that's again dependent on the business problem. But there is no easy answer to it I have found so far, right? Either you go and cry to the silicon vendor, boss, do it, or you find a large enough business problem, the silicon vendor is sold on it and just says, okay, I'll support you, right? But if these two are not possible, we will have to work on the stack ourselves. And that's work, no doubt. And that is where, we should not ignore this part, because we will typically think of the platform application. That's easier part. Yes. Sorry, if anybody else has a better answer, yes, please feel free, right? Yeah. Any other questions?
I am totally new to IoT. So I got
as good as me.
So what do you recommend? Should they start with Raspberry Pi or should they start with Arduino to play around?
Start with both. It's not very expensive, right? So that's what I was trying to say, right? So you are here.
Yeah.
So if you can afford both, please start with both, right? And what is your problem? That's the first question I will ask.
I just want to kind of explore different things, connecting a few sensors and taking an automated.
So my suggestion is please choose a problem first. Again, that is where I am coming to, right? And that your answer becomes easier that way. Because if, let's say you want to choose a healthcare problem, right? You would actually choose based on whatever healthcare sensors are available. I'm sure Arduino is a good interface for some of these healthcare sensors. So I would go with the Arduino, but I will not neglect Raspberry Pi. I'll still need something for computing whatever data is collected, right? I need to build intelligence. So you would need both plus the sensor. So if you choose an automotive problem, you may never come to Arduino. I don't know, right? Because there are some sensors, people are coming up with some kind of stickers where you can just paste it on your, say, car tire and then collect all the data into any Bluetooth enabled device. So if you are choosing that kind of a problem to go with and then working on connected or autonomous stuff, you would have an entirely different way to go. So Arduino Raspberry Pi, as I say, is a general purpose computer, right? So you can build any application over it, almost, correct? So it's a replacement to this. So if I have to choose between this or a Mac, I mean, I will first choose my problem statement, right? How important is my usability? Then based on that grade, I will choose it. So like that, that's why I was suggesting let's choose a problem first, right? And then go into platform, because we first ignore this. This is our, I think, typical. Otherwise, you can just learn Linux on a Ubuntu platform on a PC. There is no difference on a Raspberry Pi to my knowledge. All the same commands. I don't know. It's just Debian, right? It will probably take 1 hour for you to just boot up a Raspberry Pi with SD card and work comfortably with it. There's no difference. So please, I think we should actually focus on the problem rather than, this is an enabler for me, right?
Another hobbies to learn a little bit of he wasn't even IoT. He had a only class in our Chennai office, and one of the things we started with was the basic programming on the Atmel stack sensor, and then after that he set up the Arduino. On the Arduino, quite easy, it has its own SDK that you can just program, and you can try out some basic sensors on make small projects work. I think that's kind of where you are right now. So you can step it up from there to actually doing the problem.
I think correct. And I think better to start with the kit, because there are kits with sensors available. So it is easier to learn. If you're talking about learning, it may be easier to start with the kit, make something work on that as per the instruction, and then plug out few sensors and change it and see what happens, right? Then I think the learning is better. I think healthcare kit is available, I'm aware, so I was just a good one. Yeah.
I have a question.
Oh, okay. It's going to be a tough one.
So coming to fabrication, say you prototype with get like Raspberry or I don't know whatever. So you have more or less accounts with what you need. So the next step is you want to build your own fabrication. So for a hobby specifically, fabrication is going to be a lot of complexity. Okay, you build on your own, you have tools available, but how do you actually build it? Like physically, how do you build it? Like, I know, like, what will be your advice for those?
For a hobbyist.
But for in production scale, it's very much different. Right?
Yeah.
But for hobbyists, like, what do you do?
See, it is not. There are always people to help. Is a simple answer, right? And there are smaller companies who can help you fab these boards. And typically, these boards you wouldn't make it a 16-layer complex board. It won't be, right? It'll be at the most dual layer if you want to start something small. So you can actually even in Coimbatore there are a few companies. I can't get it out of my head now, but there are companies who can easily build it for you, and you can just explain your entire what you want. Then they can even help you design it, because it's not that difficult as we perceive it to be, in my understanding, right? So it just needs familiarity. And you please talk to the people and the small companies. They can help out, in fabricating your stuff. And it's not very expensive. You can just buy a Atmel chip, like you're saying, and then you can build your own board very, very easily. Atmel is one of the easiest, maybe. So I would say start with finding your small companies that actually can help you fabricate. You don't have to give them any large scale commitment. They'll charge you, of course, little more, but it's okay. It's not very, very expensive or nothing non-affordable by the crowd here, I guess. Sorry, I'm not able to give. I know some companies, but I'm not able to. Yeah, I can share it, and maybe we can share it too. Maybe. Okay. Thank you. Thank you so much. You want to use?